Hi everybody. In today's tutorial, I'm going to show you how to size a spread footing for a commercial foundation. In this problem, we're going to be sizing a spread footing for column B3, which is pictured in the image below. And based on our beam analysis calculations and what the structural engineers have already determined, is that that column is responsible for carrying 112.5 kips. One kip is equal to 1,000 pounds, so that's the equivalent of 112,500 pounds. The existing footing is 1 foot 9 inches, and the footing is resting on silty sand, which has an allowable soil bearing pressure of 3,000 pounds per square foot. Now, what we're checking here is to see if the footing thickness is actually thick enough or if we have to pour new footings. So I'll show you how to calculate that step by step. As we're looking at these problems, the pieces that are highlighted in yellow are going to be really important pieces of information for us to actually plug into our formulas. So I'm going to be referring back to this slide to cross-check some of this information so you can see how it's used in the future calculations. Our first step is to calculate the allowable soil-bearing pressure. Typically, this is going to be information that will be included in the scenario, like it was for this example, but in other times you might have to refer to the table that's pictured here below to figure out the different soil-bearing capacities. In this problem, we know that the allowable soil-bearing pressure, which we call Q, allowable, which I'll just shorten to allow, is equal to 3,000 pounds per square feet. And this can also be written as 3,000 PSF. The next step is figuring out the soil-bearing pressure due to the weight of the footing. So the first thing we need to do is figure out the total weight of the footing. Based on the thickness of the footing, which was given to us in the problem, it's 1 foot 9 inches thick, multiplied the weight of concrete, which is 150 pounds per cubic foot. Now the thickness of the footing, T footing, is going to change from problem to problem. The weight of the concrete is going to remain constant with any problem where you're calculating the size of a spread footing. To put this all together, to calculate my P footing, I'm going to multiply the thickness of my footing, which is 1 foot 9 inches, and we're going to convert that to decimal feet, so 1.75 feet, multiplied by 150 pounds per cubic foot to get 262.5 pounds per square foot, or PSF. My next step here is to actually figure out how much weight my soil can now hold now that we've calculated the weight of the footing. So we are going to call this Q net, and we're going to take our Q allow from step 1 and say 3,000 PSF minus 262.5 PSF is going to give us a Q net of 2,737.5 pounds per square foot. So this means that our new soil bearing capacity is 2,737.5 pounds per square foot. So when we're figuring out what our new square footing size, we have to make sure that it's adequate to carry these design loads and that the soil is going to be able to support them. Now we're ready for step 3, determining the footing area. In this part of the problem, we are ready to apply the formula Q equals P divided by A. If we break this down, we know that Q equals the soil bearing pressure, P is the total applied load, and A is the area of the footing. So we already know the soil bearing pressure from the previous problem. We want to use Q net, which is the soil-bearing pressure minus the weight of the footing, where we got 2,737.5 pounds per square foot. We also know the total applied load, which is 112.5 kips, or 112,500 pounds. The only thing we don't know is the area of the footing, so we have to rework this formula in order to solve for A. In order to do that, we're going to multiply A on both sides, and then we're going to divide by Q. This gives us a new formula of A, the area of the footing, has to be greater than or equal to the load applied to the column, which is 112,500 pounds, divided by the Q net, which is our new soil bearing pressure. So when we put it all together, it's going to look something like this. We know that A has to be greater than or equal to 112,500 pounds divided by our Q net, which is 2,737.5 pounds per square foot. Our pounds cancel out, and that gives us an area of 41.095, which we can just round to 41.1 square feet. This means that the total area of our footing has to be greater than or equal to 41.1 square feet in order for it to sustain the design loads of the column. So in our fourth and final step, it's time to design the footing itself. And in this case, engineers have a few different options. They can size a column footing, which is going to be circular. They can size a square footing, which is obviously going to be square, or they can size a rectangular footing. And since we have the area, it's pretty easy for us to determine what shape we're going to use. So in this example, I'm going to show you how to size a square footing. If we know that the area of our footing has to be greater than or equal to 41.1 square feet, then all I need to do is find the square root of 41.1 to figure out the length of each side of my square footing. So if x is equal to the square root of 41.1 square feet, then each side of my footing is going to be 6.4 feet. So typically when we're sizing square footings, we like to work in 3-inch increments. So if you round up 6.4 feet to 6.5 feet, we can easily use the round number of 6.5 feet, which is equal to 6 feet, 6 inches. This means that my square footing is going to be 6 feet, 6 inches by 6 feet, 6 inches by 1 foot, 9 inches as the thickness specified in the original problem. If you want, you can go ahead and figure out the size of the footing for a circular column or for a rectangular footing. That's up to you. But now that you have these foundational skills to size a spread footing, go ahead and use this tutorial to help you throughout the practice problems. Thanks for watching.